exercise questions of the chapter Oscillations. Question 1. Which of the following examples represent periodic motion? A swimmer completing one trip from one bank of a river to the other and back. Okay, that is not a periodic motion. Next, a freely suspended bar magnet displaced from its north-south direction and released. So you can see a freely suspended magnet. Okay, so it attains north-south direction due to the interaction of Earth's magnetic field. So once it is displaced from its mean position, so it will come back to the mean position, but it cannot stay back there. It goes to the other side, so that the motion will be repeated, and it can be considered as the example for periodic motion. Part C, a hydrogen molecule rotating about its center of mass. Again, it is rotational motion and it is periodic motion. Then part D, an arrow released from a bow. So there is no element of repetition there. So it is not an example for periodic motion. Come to question 2. Which of the following examples represent merely simple harmonic motion and which represent periodic but not simple harmonic motion? Part A, the rotation of Earth about its axis. So rotation of Earth about its axis is an example for periodic motion. Then next, the motion of an oscillating mercury column in a U-tube. Already we have proved that the mercury column in U-tube executes simple harmonic motion. Then part C, motion of a ball bearing inside a smooth curved ball when released from a point slightly above the lowermost point. Okay, it will be something like that. You can take the ball bearing like this. The ball is released from here and it goes and it enters to the other arm, then it returns back, and this motion will be repeated. Therefore, we can consider it as an example for a simple harmonic motion. Then finally, general vibrations of polyatomic molecule about its equilibrium position. So here in a polyatomic molecule, there are many atoms simultaneously in vibration. Therefore, we can consider it as a superposition of simple harmonic motions. Superposition of simple harmonic motions. Then question 3. Diagrams depict 4 xt plots for a linear motion of a particle. Which of the plots represent periodic motion and what is the period of motion in case of periodic motion? The first one, okay, it is not periodic motion. The second one, of course, it is periodic. And here you can just take that. You take this point 1, this point 3. So here we have one positive part and one negative part. So for complete positive part and a negative part, the time taken is 2 seconds. The same is applicable for left hand side also. Therefore, we can take t is equal to 2 seconds. And part C, okay, it is not periodic motion. You can see there is no element of repetition there. Part D is periodic motion, and you can see there. So here the positive part and here negative part. So one complete oscillation. The same way here -1, -2, one complete oscillations. So the time taken for one complete oscillation is t is equal to 2 seconds. Therefore, that is the time period. Then question 4. Which of the following functions of time represent simple harmonic, periodic but not simple harmonic, and non-periodic motion? Give period for each case of periodic motion. Omega is any positive constant. Okay, take the first case. It is sine omega t minus cos omega t. Okay, so a simple harmonic motion or oscillation we can represent in three ways. First one in terms of sine omega t, second one cos omega t, third one a linear combination of sine and cosine. So this case is a linear combination of sine and cosine, therefore this is SHM. So how much is the time period? Here it is given sine omega t, therefore time period t is equal to 2 pi by omega. Then next, part B, sine cube omega t. As it is a sine function, we can say it is a periodic motion. If it is a periodic motion, then what is the time period? Again, you can see omega here, time period. So we can calculate the time period. Time period t is equal to 2 pi by omega. T is equal to 2 pi by omega. Then part C, 3 cos pi by 4 minus 2 omega t. So here it is a cosine function. That's only. Pi by 4 is the phase difference. So we can take it as simple harmonic motion, SHM, in terms of cosine. And here instead of omega, you have 2 omega is there. Therefore, t is equal to time period formula is 2 pi by omega, but we have 2 omega here. So time period will be pi by omega. Then part D. Part D, you can see we have all cosine terms are there. So it is not the super combination of sine and cosine, only cosine. So in such a situation, as it is cosine function, of course, it is cosine function is a periodic function. So you can consider it as a periodic motion. And when you calculate the time period, okay, you can take the least value of omega. Therefore, time period will be 2 pi by omega. Then next we have exponential e raised exponential minus omega square t square. So exponential functions, okay, we write e power x or e power minus x. These two functions represents either a smooth increase if it is e power plus x or a smooth decrease e power minus x. There is no element of any repetition there. In such a situation, we can say this function is neither oscillatory nor periodic. Okay, the same is applicable for the last case also. There is no sine or cosine, so it is not at all periodic and oscillatory. Then next, question 5. A particle in linear simple harmonic motion between 2 points A and B, 10 cm apart. Take the direction from A to B as positive direction and give signs of velocity, acceleration, and the force on the particle. Okay, so here what you have to calculate, a particle oscillates for 10 centimeter like this. Okay, oscillation of the particle for 10 centimeter. So this point is A, this point B. So here the center, okay, 0. So 10 centimeter means up to here you have 5 centimeter. Let us take as minus 5 and here plus 5, because towards A to B the direction is positive, like this, positive direction. So in such a situation, what happens, you have to consider point A and B are the extreme positions and point O is the mean position. Okay. Now, First of all, we see at end A. At end A, when you see, you can see there extreme position velocity is 0. So velocity 0. Then acceleration. Acceleration is always opposite to displacement. As displacement is towards left hand side, acceleration is towards right hand side. Therefore, you can take acceleration as positive. So velocity is 0, acceleration is positive, and F is equal to ma. As acceleration is positive, force is also positive. Next, at the end B. At the end B, you can see again the velocity is 0. Acceleration, see there at the end B, displacement is towards right hand side. So acceleration is opposite to displacement in SHM. So it is towards left hand side. Therefore, acceleration is negative. As acceleration is negative, F is equal to ma again. So force is also negative. The next part is at the midpoint of AB going towards A. Going towards A. Midpoint, that is the mean position. Going towards A means velocity is in the negative direction. So we have velocity is negative, and at the mean position, velocity is maximum while acceleration is 0, force is also 0. Then next, at 2 centimeter away from B, 2 centimeter away from B, I'll mark here 2 centimeter away from B, going towards A, going towards A. Now, you can see there going towards A means it goes in negative direction. Therefore, we can say velocity is negative. Now, acceleration is always directed towards the mean position. Therefore, acceleration is also negative. And as acceleration is negative, force is also negative. Then, next case, at 3 centimeter away from A, mark here 3 centimeter away from A and going towards B. Going towards B. So here again you can see velocity is positive as it is going towards B positive direction, and acceleration is directed towards the mean position. So acceleration is positive. As acceleration is positive, force is also positive. Then next 4 centimeter away from B going towards A. So here 4 centimeter away from B and going towards A. So there, just like in case D, all three quantities are negative there. All three quantities are negative. Now, next question 6. Which of the following relationships between acceleration A and displacement x of a particle involves simple harmonic motion? Simple harmonic motion, the relation between acceleration and displacement, we have seen A is equal to minus omega square y. Y is the displacement, A is the acceleration. Here it is given x is the displacement. So we have to compare the given equations and see in which case you will get such a relation. So here the only correct answer is C, because A is there, negative sign is there. Instead of Y you have x is there, omega square is 10. Next, question 7. The motion of a particle executing simple harmonic motion is described by the displacement function x of t equal to a cos omega t plus phi. If the initial, that is t equal to 0, position of the particle is 1 centimeter and its initial velocity is omega centimeter per second. So which means it gives v is equal to omega. initial velocity. What are its amplitude and initial phase angle? Angular frequency of the particle is pi per second. Angular frequency of the particle is pi per second or pi radian per second. Okay, now let's start. So first of all, in the given equation, x is equal to a cos omega t plus phi, we take t equal to 0. So when t equal to 0, the question says that when t is equal to 0, x equal to 1 centimeter. Displacement x is equal to 1 centimeter. Therefore, you will get a 1 centimeter is equal to a cos phi because t equal to 0. So take it as equation 1. The next step, differentiate the given equation with respect to time. So you will get a velocity v is equal to dx by dt. V is equal to dx by dt is equal to, when you differentiate, you will get a omega sine omega t plus phi. So what you have to do? First you have to differentiate the function. When you differentiate cos omega t plus phi, you will get a minus sine omega t plus phi. Then again omega t you have to differentiate. When you differentiate omega t, you know omega is constant. So constant you can take outside, then dt by dt it will be cancelled. So differentiation you have to see. So you'll get this equation. Now, so you will get velocity, and there you take a t is equal to 0. At t is equal to 0, v is equal to, you will get a minus a omega sine phi, minus a omega sine phi. Now question says that in the beginning v is equal to omega. Substitute there. So omega is equal to minus a omega sine phi. Now omega cancel. So you will get a sine phi is equal to minus 1. Take it as equation 2. A sine phi is equal to minus 1. Now what do you have to do? Equation 1 and 2 as usual. Okay. We have to square and add. So you will get 1 square. Here minus 1 square will come. So minus 1 square is again 1 square is equal to, you have a square cos square phi plus a square sine square phi is equal to, here it becomes 2. Then here a square you can take common. So you will get a cos square phi plus sine square phi. So cos square theta plus sine square theta is 1. So you will get a square is equal to 2 or a is equal to root 2. A is equal to root. Now you can divide equation 2 divided by equation 1. 2 divided by 1, you will get a and a will be cancelled. Sine phi by cos phi become, okay, sine phi by cos phi is equal to minus 1. Sine phi by cos phi is tan phi. So tan phi is equal to minus 1. So tan phi minus 1 means, you know, it will be something like that. If we have values of sine and cos are equal. Values of sine and cos are equal means That will happen at 45 degrees. Sine 45 is 1 by root 2, cos 45 also 1 by root 2. That's why you are getting 1 here. Therefore, you can take phi is equal to, here on minus 1 also there, minus 45. 45 degree means it is pi by 4. It becomes pi by 4. Pi by 4 means 45 degree. Okay. And if you apply trigonometry to avoid this negative sign and all, okay, then it will come like this. Actually minus pi by 4 is enough, but you can take like this. Tan phi is minus 1, so that is tan minus tan pi by 4. Minus tan pi by 4 means it is tan, that minus sign we can take it inside, then it becomes tan 2 pi minus pi by 4. Okay. Tan 2 pi minus pi by 4. So those who have studied mathematics can solve these steps and all. Okay. So therefore you will get that angle phi is equal to 7 pi by 4. Okay. So any one of the answers. Now the question continues. Solve the same problem taking the formula x is equal to b sine omega t plus alpha. Okay. So follow the same method and solve the problem. Try to solve yourself. And here I have given that answer for your reference. Okay. Now next question 8. A spring balance has a scale reads 0 to 50 gram. Okay. That means its maximum measurement is up to 50 gram. And for measuring 50 gram, the scale has a length of 20 centimeter. That means maximum length is 20 centimeter. A body is suspended from this balance. When displaced and released, oscillates with a time period t 0.6 second. What is the weight of the body? Okay, now, so you can take like this, mg is equal to kx. Means F is equal to kx, you know. Here the weight attached, so force is mg. Mg is equal to kx. Now mg is equal to kx and maximum mass is 50. G is equal to k into for 50 kilogram maximum measurement is 20 centimeter. So convert into meter, 20 into 10 power minus 2. You can substitute the value of G also there, and you can find the value of spring constant K. So you will get the value of spring constant K that you have to calculate first. Then afterwards, time period formula you have to use. T is equal to 2 pi into under root 2 pi into under root m by k. 2 pi into under root m by k. Now t is given 0.6 seconds. So now you know the value of k. So square this equation. Okay, then find the value of m. M is equal to t square a divided by 2 pi. So you get the value of m. Once you get the value of m, you are asked to calculate the weight of the body, that is mg. Weight of the body mg. Now, next question 9. A spring having with a spring constant 1200 Newton per meter is mounted on a horizontal cable. A mass 3 kg is attached to the free end of the spring. The mass is then pulled sideways for a distance 2 cm and released. So it is pulled sideways 2 cm. So what is that actually? 2 centimeter. It is a maximum displacement. Therefore, the maximum displacement amplitude 2 centimeter you can take here. Amplitude 2 centimeter. Okay. Determine the frequency of oscillations, maximum acceleration of the mass and maximum speed of the mass. How can you calculate the frequency of oscillation? You take the time period formula. T is equal to 2 pi into under root m by k. 2 pi into under root m by k. Once you get the value of t, okay, you can find, okay, you find the value of t. Once you get t, you can find nu. Nu is equal to 1 by t. So you will get a frequency of oscillation, first answer. Now maximum acceleration. Once you get frequency, then you can calculate the value of omega. Omega is equal to 2 pi nu. So you will get the value of omega. Once you get the value of omega, you can calculate the maximum acceleration. Amax is equal to minus omega square r. Substitute the values of omega square and r, you will get the answer. Then maximum speed, Vmax is equal to r omega. So substitute the value of r and omega, you will get the answer. Next, question 30. Figure shows a spring of force constant K clamped rigidly at one end and a mass M attached to its free end. A force F applied at the free end and stretches the spring. Okay, and figure B shows the same spring with both ends free and attached to a mass M at either end. Each end of the spring is stressed by the same force F. So understand the situation given there. Now next, what is the maximum extension of the spring in two cases? Maximum extension of the spring. So maximum extension of the spring, you can see here, it is like that this end is fixed edge, this is free edge. So in the first case, the maximum extension xm will be equal to F by K. F is given, K is spring constant, F by K. Okay, because F is equal to K xm. Now the second case, okay, so when these two masses are here, you can see when you pull this spring with a force F, actually there is a reaction which is applied on this fixed point. So we have action and reaction. Now here, when you, the second case, you can see when you pull the bodies on either direction, okay, the middle you can take like this. And the first case, case A and case B, you can compare. Here these two forces, here I told you, you applied one force, reaction is on the fixed point. Here instead of that, you can see one force you can take as the action and other one can be considered as the reaction. Here also you have action and reaction on the fixed point. So both are same situations only. Therefore, in case B also, xm will be is equal to F by K, because same spring, same force, same spring constant. Here also force F will be the reaction and other side also. Here also F is action and other F is the reaction. So extension of the spring will be same in both these cases. Then afterwards, okay, come to part B of the question. Part B, if the mass in figure A and two mass in figure B are released, what is the period of oscillation in each case? So in the first case, okay, period of oscillation is our usual formula, T is equal to 2 pi into under root m by k. Now in second case, you can consider it like this. Okay, with the middle, so both the masses are oscillating now. So you have to imagine like that. The center is the fixed point, and two springs are in oscillations. So it is the oscillation of two springs with the center fixed. In such a situation, the spring constant changes k dash is equal to 2k. K dash is equal to 2k. How you get k dash is equal to 2k? You can have a reference, okay, of the uh, solved problem 14.6. A similar situation is given. Their spring constant is calculated. So you will get f is equal to minus 2kx in such a situation. So k dash is equal to 2k. Please refer question 14.6 solved question. So accordingly, in case B, the time period becomes t is equal to 2 pi into under root m divided by 2k. M divided by 2k. Next, question 14. The position in the cylinder head of a locomotive has a stroke. Different strokes in engine and all you have studied. Tau is the amplitude, means stroke means tau is the amplitude is equal to 1 meter. So 2r is equal to 1 meter, or the amplitude is equal to 0.5 meter. That is what given in the question. If the piston moves with a simple harmonic motion with an angular frequency omega 200 radian per minute, what is the maximum speed? Okay, so here radian per minute you have to convert to radian per second. 200 divided by 60 radian per second. Now maximum speed only you are asked to calculate. The formula is v is equal to r omega. R is given, omega is given, so that the speed can be calculated. Then question 50. The acceleration due to gravity on the surface of moon is 1.7 meter per second square. Take it as g moon. What is the time period of a simple pendulum on the surface of the moon? So time period on the surface of the moon, Tm, you have to calculate. If its time period on the surface of Earth is 3.5 seconds, T is 3.5 seconds, then G on Earth is 9.8 meter per second. That is G. So these are the quantities given, and Tm you have to calculate. What you have to do? You have to take formula first. Te, time period on Earth, is equal to 2 pi into under root L divided by G. Now time period on the moon, Tm is equal to 2 pi into under root L divided by GM, L divided by GM. Now you take the ratio Tm by T. So you will get Tm divided by T is equal to under root G by GM, or cross multiply the equation. Tm is equal to T into under root GE divided by GM. Substitute the values and find the value of Tm. Then we move to question 24. A body describes simple harmonic motion with an amplitude of 5 centimeter. Amplitude is given 5 centimeter. R is given 5 centimeter. R is equal to 5 centimeter. And period T 0.2 seconds. Find the acceleration and velocity. Two quantities you have to calculate, acceleration and velocity. When the displacement is, three cases are given. So first case, when the position is 5 centimeter. So 5 centimeter means, it is in the extreme position. At the extreme position, velocity is equal to 0. Acceleration is equal to minus omega square r. Omega is not given, but time period is given. So 2 pi by t, the whole square into r. The quantities are given, so you can calculate the value of acceleration. Now next, case B. Case B, 3 centimeter. 3 centimeter means that is a displacement in between, which you can take as y. So now, first upon velocity. Velocity is equal to omega into under root r square minus y square. Formula you have studied is equal to velocity you can calculate. Then acceleration a is equal to minus omega square y. Ensure that the values are substituted in SI unit, numerical values. Okay, then next part C, 0 centimeter. 0 centimeter means r is equal to 0 and velocity v is equal to 0. Oh, v is equal to 0 we have already taken. So velocity will be maximum velocity, displacement y is equal to, so actually the displacement y equal to 0, r is amplitude, displacement is 0, so v is equal to maximum velocity will be there, v is equal to r omega, and calculate the value, and acceleration is minus omega square y, as y displacement y is equal to 0, acceleration is 0. Now question 25. A mass attached to a spring is free to oscillate with angular velocity omega in a horizontal plane without friction or damping. It is pulled to a distance x0 and pushed towards the center with a velocity v0 at a time t equal to 0. Determine the amplitude of the resulting oscillation in terms of the parameters omega, x0 and v0. Use the formula x is equal to a cos omega t plus theta. Okay, the same we have seen almost in one of the previous questions. Anyway, that's all. We will start from the formula x is equal to a cos omega t plus theta. Now, when t equal to 0, when t equal to 0, it is given position is x0. x0 is equal to a cos theta. x0 is equal to a cos theta. Now differentiate the equation. You will get velocity. V is equal to dx by dt. Dx by dt is equal to, you will get a minus a omega sine omega t plus theta. Okay, when you differentiate cos omega t plus theta, you will get a minus sine omega t plus theta. Again, you have to differentiate omega t, then you will get a omega. Then here in this equation, take here time t equal to 0. When you take time t equal to 0, question says that velocity will be v0 at that situation. So you will get a minus a omega sine theta when t equal to 0. Now we have the formula v0 is equal to okay, so take this v0 formula, then keep the minus omega outside, then the remaining part, the same thing we have done in the derivation also, the remaining part you can square and take the square root, so sine square theta, so is equal to minus omega into minus omega into under root a square into sine square theta is 1 minus cos square theta. Sine square theta is equal to 1 minus cos square theta. Therefore, this is equal to minus omega into under root a square, open the bracket, a square minus a square cos square theta. Therefore, V naught is equal to minus omega into under root a square minus a cos omega t is x naught. So x naught square. Now you can square this equation. When you square this equation, you will get V naught square is equal to omega square into a square minus x naught square. And you are asked to calculate the value of a. So rearrange this equation. A is equal to under root x naught square plus V naught square divided by omega square. Okay, so that is the final answer.